So this is our talk on mastering Git. Start off with thanking the sponsors for sponsoring the event so that we can all be here today.
Thanks for feeding us.
So a little bit on who we are. I'll let you
All right.
go first.
Sure. I'm Ryan Richter. I'm a senior support engineer at Chocolatey Software. I'm pretty much at Ryan Richter 94 on all the social medias, as you can see there. I consider myself a little bit of an intermediate Git user from the perspective of this talk. I use it in my day-to-day, but not so much as our development team and some other people.
And I'm Cory Knox. I'm a software developer at Chocolatey Software. Prior to Chocolatey, I worked doing end user computing support for a tire retailer in Canada. And I've used Git, I guess, professionally for the last 5 or so years, and unprofessionally for the last 2 or so weeks. I have used Git quite heavily, and been using it and learning more about it just as I just do everything. I'm not as smart as Ryan. I don't have the same handle on every single social, but it is either Corbob or some variation of Cory Knox, or in the case of LinkedIn, Knox Cory, because some other jerk named Cory Knox took the way I want it. So we'll start with a bit of a full disclosure. Ryan and I both work for Chocolatey Software, but this is not the views of Chocolatey Software. These are our preferred methods of using Git, and there are definitely more ways of using Git than what we're going to cover and learn about today. There was something else I wanted to make sure we cover, but oh yes. So while we work for Chocolatey, this isn't their views, and it's not necessarily the way that everyone at Chocolatey uses Git. A lot of it comes from the way that we use Git at Chocolatey, but that's sort of that. You do the.
We're slightly corrupted, but we'll show you how we do it.
Yeah. So, do you want to cover questions?
Yeah, we're going to be covering a lot. If there's something that you need assistance with throughout the presentation, just put your hand up, or just audibly say, "Hey, I need assistance" or whatnot. We'll be happy to come around and help you as we work through the workshop part of this.
And any questions, we will repeat them for the recording, so that they're able to be picked up in the recording. And so we'll move on into the workshop, if I learn how to use the clicker properly. So the workshop objective that was may or may not have been written by ChatGPT says that Git is a powerful version control system used in DevOps to keep track of changes in files and collaborate with others efficiently. Now, what does that mean? We're not entirely sure, because like most things in AI, it just kind of makes things up. But I would take it to mean that in order to be efficient, you need to know all of the commands that are in Git.
Aren't there quite a lot of those? How many are there?
That's an excellent question. How many? If we go according to the documentation, there's a handful, and they're kind of split up into various buckets based on what they do. And so there's the porcelain commands and the plumbing commands. So the porcelain is kind of what you interact with, and the plumbing is what the porcelain interacts with. They apparently have decided to model it off of a bathroom, and I'm just realizing there are so many there's so many things observations I could make about that. Now, in these two buckets, there are smaller buckets because it's buckets all the way down. Under porcelain, there's main, which are the commands that are the main commands. Then they also have ancillary commands that do ancillary things. Interacting with others is a bit of a misnomer. It's not actually interacting with other people. It's interacting with other version control. And then under plumbing, they fall under manipulation, interrogation, syncing, and internal helper commands. I just realized I didn't hit start on my timer. So we're gonna be a little late for a break, maybe. And so inside of these buckets, there are 44 main commands, 29 ancillary commands, 10 for interacting with others, 20 for manipulation, 21 interrogation, 11 for syncing, and 18 for the internal helper commands. And so that begs the question of like, really, how many are there? And so it turns out, by my count of those, and you'll get different answers depending on how counting works, apparently, because I've seen talks where they didn't get the same number. There's 153 commands. So
that seems like way too much to cover in this talk, Cory.
yeah, some might say that it's too much. So then, if that's too much, how many do we want to, or how many are we going to cover? Well, so we've got the plumbing commands that has 70, and as I said, that's the porcelain interacts with the plumbing to do what it does. And so we won't talk about those at all, and nor interacting with others, because as I said, others is a bit of a misnomer. It's interacting with other version controls, and you don't really do that often, or at least I haven't found the need to do that. So that leaves us with, I should have counted this before, 73. And I did count it before. But 73 still sounds like a lot. So we're actually going to say 3 for the ancillary commands and 21 for the main commands. So that brings up us to the next part, which is which commands are we going to cover? If there's 153 and we're only covering 44, it's good to know which ones they are. So we'll go over config, which is used to configure Git on your system. Init, which is, this is going the wrong direction. So init, which is used to initialize your Git repository. Checkout, which is used to move around in the repository, check out files, check out branches, and various things in the repository. Status.
Basically get where you're currently working.
Yeah. So, sorry, this is, I made a change to the slide this morning, and now it is bringing these up in a different order. So add, which is used to add files into the index, which we haven't covered. So it doesn't make sense that I'm telling you about add right now, but we'll just keep going with it because that's how it works. We use commit to commit your changes. Log to shows you the history of your repository and the messages that are on all of them.
Hey, Cory, how about git show? We just show them the rest of the commands.
We'll try.
Okay, let's do it.
Because what's supposed to happen is it's supposed to show you all of them, and it's not. So pro tip, if you're speaking, test it, and don't make changes
Last
15
minute.
minutes before your talk. So those are all the commands that we're going to cover. There is 24 of them. It was originally supposed to go across the top and then to there, which is why I got confused by all these ones. But, you know, do it live. So these are the commands that we're going to cover. So what does our rough plan look like? I'll let you cover the rough plan, because
Of course. Well, we have a little bit of story time with Cory here about version control systems and how all of that in the before times, we'll call it, before Git. As well as we'll cover what is a Git, why is Git, okay, but which Git, installing Git, using Git. There's a part we really don't know. We're going to make it up.
which apparently we're making most of this up anyways.
Exactly. Do it live.
Perfect.
And then, of course, lastly, you have profiting the Git.
So then, naturally, that means that it's story time.
Exactly.
Story time with Cory. So to understand what Git is and how to use Git, you kind of need a backstory, or maybe you don't, but I'm going to pretend you do. And I'm the one leading the workshop, so I get to decide. So the backstory is starting with what is version control, and I had intended for not all of this stuff to be shown on the screen, but again, this is how we roll apparently. So version control is effectively a way to help you manage changes to your files. It allows you to go back to previous versions of a file, as well as kind of see changes over time. And I'm reading my notes, and we noted this needs more content, which is perfect. So we'll leave screw the slides for now. What does version control look like to various? Actually, it's a workshop. It's supposed to be interactive. What does a version control look like in your organizations, or in your day-to-day lives? Yeah. So said it's the OneDrive in Office showing you the previous iterations of a file. I know now that I think about it, it's funny, it doesn't seem like it. I've been a member of Toastmasters for a few years, which is why there are absolutely no uhs and ums. If anyone from my Toastmasters group asks, I did perfect. And I'm definitely, but one of the things that we do there is we have events that need posters, and being the non-technical group, they end up regularly with sending off an email to the group saying, here's what I suggest for the poster, and then someone else comes back and says, well, okay, but we need to make sure we add this part. So then you edit the file and you send it again, but you want to make sure they know which one it is. And so you say, use this one, or copy, or final, and then you get to what I put on the slide there, and coincidentally, the name of this document is Summit Talk Final Copy for Use This One. Because inevitably, that's just how, at least in my experience, non-technical people do version control, is they just do it however they need to do it. And so this leads to the problem of, well, we need to do version control. We need to be able to go back and look at our files from the past and see what has changed, And particularly if we've taken something out and then we realize we want it, whether it's for that same project or something else, we need to be able to get out and do it. And now, when I was growing up, we used these for that. They weren't zip tied together, but these were the only ones I still have left. So for those who aren't as old as me, these are floppy disks, and they hold a whopping 1.44 megabytes. And you used to be able to put everything on one of those. Then we moved on to CDs. And you end up with backup and mixed data. And I honestly can't tell you what is on any of these, but it was versioned and there was control over it when I burned those.
I'll be honest, Cory, back in my day, it was mixtape 1 and mixtape 2.
See, but I actually had tapes. So, and actually, to be fair, I have, and we've all seen USB keys. That is also, it turns out, a method of version control that is used by some rather large projects if the one random tweet that I saw is to be believed, and it's on the internet, so therefore it is true. Pal World, which I don't know if anyone's heard of it. I've seen it described as Pokemon with guns, which again, it's on the internet, must be true. They apparently had buckets of USB keys, and they would grab one, make their changes on the USB key, and at the end, someone just took all the USB keys and merged it all together. And that was their version control, which is not terribly great. But in my experience, the process of getting to version control is much like this image from Twitter, but in kind of reverse. You start off with your project in a folder, and then you need to make changes, but you want to keep the original changes, so you copy the folder, and then you end up with project with 2 T's and project with 7 T's, and so on and so forth. And then you decide, well, no, we need to give it better names, so you end up with project revised. Finally, you say, well, version numbers, that's what?
No one can name anything, so version numbers, yes.
Version numbers, Microsoft does it, and they do a great job. 1, 2, something, 7, 10, however that joke about counting goes when you're Microsoft. So, and then eventually you come to the realization that a system like Git is what you want, and so you use Git. What I had actually kind of hoped was to, if I had been editing my slides this morning, which I definitely wasn't, I would have actually flipped this one upside down and just pretended that it was in the right order. But again, I didn't edit them this morning, so I didn't have a chance to fix that. So
now that we know why we need Git, maybe looking at how did we get to Git?
How did we get to Git? So then we'll have a brief, incredibly incomplete, and probably inaccurate history of version control systems. And so naturally we start off with, well, back in my day, and I did kind of cover the floppy disks and stuff, but the history of version control actually goes back like pretty much to the dawn of computers. In the early 60s, there were punch cards. And according to this chart, because believe it or not, the 60s predates me. So I'm trusting the internet to be correct. And it's not Twitter, so it might not be correct, but we'll hope. So there was a system that came up for IBM punch card systems. And then in 72, there was a new source code control system. And the one that I actually I've actually heard of and been alive for at least some of, was the revision control system. Is the earliest that I actually remember is or hearing about. I don't know. I might have used it as a in my younger days when I felt that using obscure things was a smart thing to do. We use revision control system. And then after that, concurrent versioning system is actually what I cut my teeth on. We used it at college. It's a system that allows you have a central server, and you can check out the files. Only one person can check out a file at a time. And it worked for a number of years. And then in about 2000, Subversion was created as a successor to concurrent or CVS, the concurrent versioning system. And Subversion was also great, I guess, for its time. It also was centralized, and this is where, kind of in 2005, is where we get to the like modern, I guess we would call modern version control systems, such as Git. And Git was created by Linus Torvalds over 1 or 2 weeks, I think, which might explain a lot of Git's eccentricity. Yeah, that word. Might explain why Git is so convoluted and complicated to use and eccentric. It was created by Linus Torvalds, who created the Linux kernel, and as with a lot of things in Linux and Unix world, they like to keep things short, use obscure arguments and whatnot. But one of the big things that gives us is distributed version control, because previously under Subversion and concurrent versioning system, you had a central server, and in order to work on anything, you had to be able to talk to that central server to get your changes back. And Git distributed all of that to the users, so that on your computer, unless you tell it otherwise, you have the full history. I have Wi-Fi right now, but if I turned off Wi-Fi, all of my Git repositories, I can still work in them. In around 2005, probably a little before and a little after, there are other systems that have come out. There's Mercurial is one. And Mercurial is actually the only one I can think of right now. There is I can't remember the one I worked with at a company in between 2008 and 2010. We worked with one that it wasn't concurrent, or it wasn't distributed, but it was a competitor to Microsoft Visual Source Safe. If anyone has heard that name and didn't run out of the room screaming, I am shocked, because the rumor has it that even Microsoft wouldn't use Visual Source Safe, and because it had a habit of corrupting things and losing your work, which is not good in a version control system. I don't know what any of these animations are, but so that's kind of the history of Git and why we got to Git. And actually, I didn't even cover that Git is what's called a directed acyclical graph. And so the way Git works is that when you have a commit, it contains all of your data for the change, which is your commit message and everything that changed on the file. And then it points to the previous change. And that one points to the previous one all the way back to the beginning. And you can branch off and have changes that diverge. But the one thing you can't do is either self-reference, so you can't point back to at your commit that you're putting in, or you can't have it's acyclical, meaning that it can't have cycles. It can't have circular references. So you can't have A reference B reference C, which reference back to A. You can have A reference B, reference D, and B also reference C. But again, like it doesn't let you do any of that stuff. Carrying on into, I think this was one of the ones we had on our rough plan, but we called it why Git, or why is the Git?
Yeah, why is the Git, or why learn Git effectively.
Yeah.
In the presentation.
Do you want to cover some reasons?
Absolutely. Yeah. Git has become pretty much the industry standard for source control at this point. It's very odd that you're using Mercurial. If you are, I mean, it's out there. But for the most part, Git is kind of the tool for version control. It's, if you're in the DevOps space and programming at all, even in the open source community, that's how code is shared these days, is pretty much through Git. The other thing is information around using Git is so readily available. There's tons of resources online. They have great documentation themselves, again, over all of the commands.
Well, they have better documentation now.
Yes.
There was a joke for a time where someone had, before the advent of ChatGPT, someone had come up with a system that generated a random Git command and told you what the help was. And it looks surprisingly like ChatGPT generated. So maybe it was the precursor, but it was, the joke was when you put 5 or 6 of them together, where like 4 or 5 of them are actual Git commands, or the help for Git commands, you couldn't tell which one was the real one or which one was the fake, because what makes perfect sense to Linus Torvalds doesn't make perfect sense to most other people.
Exactly.
So,
kind of the last thing as well is it's a marketable skill. I mean, pretty much any job today, you put it on your resume, learning Git as a useful resource. Again, that allows you to work in the open source community. It allows you to work with code bases today effectively.
Yeah, and perhaps the most important is that Mark Rusinovich has said that Git is the bane of my development process. It's so easy to get into a state where you have to speak a magic incantation known only to the Git wizards who share their spells on Stack Overflow to get things fixed without losing changes. So clearly, if you learn Git, Mark Rusinovich will think you're a wizard.
Absolutely. Who is Mark?
Who's Mark?
Yeah, Mark who?
Mark Rusinovich.
And I was the inventor of PowerShell.
The inventor of PowerShell.
No.
Right?
No.
No?
This is a conference on PowerShell.
It says Mark Rusinovich.
That's Jeffrey
And-
Snover.
Who is that? That's Mark, right? Does anyone know who Mark is? So in all seriousness, that actually is Jeffrey, as we all know. And Mark Rusinovich is the, for those who don't know, which apparently, I thought everyone knew who it was, but
I did not before making this.
Mark is the CTO of Azure, and he's the author of the sysinternals tools, which are deep.
I've used those.
You've used those, and they dive deep into the depths and the scary places of Windows. And so I figured if he doesn't like Git and he knows all these things about Windows, is probably a good idea to know Git. And so what makes a Git, I think, was another one of our rough plan. I totally should have actually written it down so I'd know when we got to them. But, again, I had this totally prepared and wasn't working on it just as we were starting. So Git, this is just some vocabulary. The Git roughly consists of a working tree, staged stage content, sometimes referred to as an index. Commits, remotes, and branches are kind of what we're going to work off of. Commits are the data that make up your change sets. And then remotes are actually other places that Git lives, basically. And finally, branches are what we showed on that earlier slide of the various different folders with names is basically how you can think of branches. And we actually have slides to actually explain a lot of them. So kind of starting with the high level there. So the working tree, often referred to as a working directory. This is the main location of your work. This is where you're working in, either at your PowerShell terminal or in VS Code or Visual Studio or Notepad++ or whatever you're working with, and it's where all of your files live and all of the code lives. From your working tree, it will move into stage content, which is, as will become important later in some of the other information, it's often called an index, and Git itself refers to it as an index. So if you're ever reading output and it says index, this is what it refers to. And this is content that you have, after you've done editing something, you stage it into the staging area, and
basically it's the difference based off what you've begun to work with and what differences you've put into the document.
Yeah, and the difference between it is effectively the difference between the commit and what you're about to commit.
Yes.
And commits can get complicated. They are pointers to private or previous changes with messages and dates and such. So a commit will have who committed it, what day and time they. There's actually a number of date and times on it. There's like an authored date and a committed date, and just a list of the changes of what's changed since the previous one that it'll point at. Expand how commits work. And so commits are really the essential building block of Git, and they make up the.
They basically are,
tree.
when you're looking at a graphical representation of Git, mainly you're looking at your commit history at that point to see what has changed at certain points that kind of make up that graph.
Yeah. And so from commits, then we have remotes, which are other Git repositories. They're often not on your computer, and examples of ones that I'm sure most of us are aware of would be GitHub, GitLab, Azure DevOps, Bitbucket, and I believe I saw recently that SourceForge is also doing Git now for the software that hasn't moved off of SourceForge. So, and kind of a remote is Git's way of for being distributed, because as we mentioned there, it's a distributed version control system, but by being distributed, you kind of need to know where at least one other one is if you're going to interact with another repository. And then branches are different. So branches are, as I said, they're like the folders. They're the ways that you can keep track of different changes. You can work on one project or one. Say you're fixing a bug in your code, and something comes in and you need to fix another bug, higher importance one. You can switch. You could create a new branch to work off of, so that you're not mixing your one bug with, I shouldn't have said bug. Start off, you're working with a feature, creating a feature, and it's partly implemented, but a high priority bug comes in. You're not gonna just pull that bug or you don't want to work on that bug in the middle of your feature because you're probably not in a state where you're ready to release it. And so that's where branches will come in. And they're just a collection of commits and allow you to keep separation like that.
Yeah, absolutely. Mainly your branches are kind of how you release, again, like you said, certain features or certain bugs and kind of segment out that work off of a higher body of it or remote at that point.
Yeah. And so naturally, a question that's going to come up is whether you use CLI or the GUI, because there are a lot of Git GUIs, and I want to say there's more than one CLI, but it's effectively only the one. There are other tools, but definitely, in my opinion, you should start with the CLI because it allows you to access all of Git, and many GUIs a lot of GUIs, at least as they start, they just run the Git command under the hood. So knowing what they're doing, it will help you when the GUI inevitably isn't able to handle the situation that it gets itself into, which does happen from time to time. But I think an important thing, and so we put a link up here about GUIs. There are, the Git website lists a number of GUIs, and with the GUIs, it's ultimately, I think, a personal preference as to which one you use, if you do use one. There's also Git built into version control.
Operating system? Or...
not GUIs in operating systems, but in like VS Code has a Git integration, as does Visual Studio, and most of the editors that are designed for development will have Git integration, or they'll have SCM integrations for source control modules.
Yes.
I think is what the M is, and they'll have at least plugins for these source control. But one thing I read actually just recently is this saying about it's not a tool to replace another, but a tool to complement the other. And that's, I think, an excellent way to compare the GUI versus the CLI in this instance. The GUI is not a replacement for the CLI, but it does allow you to augment and complement it. And as well, on top of CLI and GUI, there are PowerShell modules that can help with your Git integration. One that I really like is PoshGit. It allows you to tab complete a lot of things that otherwise would be quite painful to have to type out or have to remember. In the case of my branch names that end up really long and then I regret it because I have to type it out every time, it solves it. I can just hit tab and it fixes it. There's also one called uGit that wraps around Git and gives you objects back, and not just like objects based on the output from Git, but objects that actually, yeah, mostly wrapped around, but objects that are like fully featured. You can take that object and interact with it just like you would any other one. So
the big kind of difference I would say between the CLI and the GUI is with a GUI, you have a back button, but that only works so often. With where the CLI, you can really get into the Git interface and truly revert back your changes as well as know how to go forward with it. A lot of the GUI interfaces, at least when I started learning Git, were really helpful in that you kind of became reliant on them a little bit, to where with the CLI, you didn't really know what it was doing. You just knew where in an interface to click to get your work done. Where learning the CLI actually gives you the full breadth of tooling under the hood of Git to really understand how your work is moving from creation to pushing it up to a higher body
Yeah.
for approval.
Yeah, and actually one of the other things that we rehearsed, and I totally forgot until now. One of the other reasons that I highly recommend CLI and learning from the CLI is probably the main reason we're all at the PowerShell and DevOps Summit is that we like to automate things. And I'm not sure about you, but the last time I tried to automate a GUI process, I wanted to do a lot worse, or some not good things to the developers of the GUI that I had to try and automate. So, so now we've kind of covered what is Git, why is Git, I think.
Yeah.
And now an important part is installation of Git, because you can't use Git without actually having it installed. Fortunately, it is relatively easy to install. If you're on Mac OS or Linux, there is a non-zero chance that you already have it installed. With that, there is also a non-zero chance that it's an old version. I know the last time I looked with Mac OS, even with the latest Mac OS installed, it was still several years behind, which sometimes is fine. With Git, it's also probably fine, but Git is actually also currently very actively developed. There are, one talk I saw recently was 1,000 commits in a time period, and now I can't remember that time period. It was either 1,000 commits, probably over a year, now that I'm thinking more about it. But so it wasn't a year, because I think it worked out to about 10 a day. In any case, Git is still actively developed. It's also actively developed by people at Microsoft and some very smart people to figure out some of the stuff they figure out, because I have tried to create bare bones Git, and it's painful. So now, if you happen to not be on Mac OS or Linux, on Windows, it's also relatively straightforward to install. You can try to install Git, or you can winget install git.git. You can also download it from Git SEM. And then from Git SEM, or once it's installed, then you're able to start using it. So I guess we'll go over what I was kind of envisioning is we'll go over some commands, and then we'll demo the commands, and anyone working with a laptop can work through the commands as we're going, and ask questions about them kind of as we go, and kind of try and build the commands upon each other. So I'll start off with the git config. As briefly alluded to earlier, it is a command used for your configuring of Git on your system. It's the help text describes it as get and set repository or global options, which is, that's what it does, but it does a bit more than that. It's usually the very first command you're going to run once you're done installing Git. You're going to need to run git config, otherwise it's going to yell at you when you try to use it, unless you're in Active Directory, which it might not yell at you, but it might not get the right information. And so a bare minimum configuration, you'll use git config, and conveniently the next slide is about the workshop time. But you'll run git config with the -- global flag, and then the configure options are, I've just read the help of this the other day that explained it, but it's period delimited, and so you'll have a section of the config file, and then kind of the variable in that section. So user.email is what you would use to set your email address, and then user.name to set your name. And this new one, I put it under as bare minimum, and I realized the notes are actually on the last slide. So, but this help.autoconfig or autocorrect prompt is one that I actually just learned maybe about a month ago. And I would highly recommend that everyone sets it to prompt or a different value. I'm gonna back it, if I push the right button, I'm gonna back it up because to read my notes about help.autocorrect. So if Git detects typos when you're typing an error, I'm sure we've all run into it where we run a command at PowerShell and we typed the command wrong. And then PowerShell yells at us and says, hey, that's the wrong, I don't know what that command is. Git tries to be helpful to you and it'll say, hey, you typed in omit, but there's no command called omit. Did you mean commit? And I grumbled all the time about this. It's, why are you suggesting it to me when you know what the command is? Just run the command. It turns out there's a setting for that. The default is to just show you the suggested command, say, hey, you typed it wrong. I think it was this one, and leave it at that. You can also set a value of a positive number, which is to run the command, suggested command after specified deciseconds. And this comes into the eccentricities of Git, is that it uses deciseconds, which are tenths of a second instead of, I don't know, seconds, and then just allowing a decimal place. But so if you were to set it to 10, it would wait 1 second. Immediate, it'll just run the suggested command. Prompt is, it'll prompt you and then you can just say yes or no. And never is, it'll just say, hey, that was the wrong command and leave it at that. I would kind of argue that never would have been a better default, so I wouldn't grumble about it, but apparently maybe actually having the suggestion and me grumbling enough about it told the YouTube algorithm to show me some video where someone talked about it. But they're definitely not listening to us, so that can't be it. So we got that's the kind of the bare minimum configurations. And this is where we have a slide where it says workshop time, and where I'm gonna work through the parts that the few parts that we've covered so far, which is on this Windows 11 VM, I hope, that it was working. Oh, come on. I kind of actually need that VM. It wouldn't be a demo without things going wrong, would it? Okay. You know what? We'll just reset the VM and hope that I changed those settings before. Good, I did. So this is a relatively bare bones Windows 11 VM that I hope will start up because otherwise I have to demo with the live system, which gets a little tricky. Oh.
Thank you, Windows.
Tomorrow's Patch Tuesday, right? No? Tomorrow, okay. Because I patched it like a week ago. like I might have joked that I was going to patch it just before, but I would certainly not actually do. I would only edit my presentation right before.
There's levels to the insanity.
I mean, I have a snapshot. Okay, maybe it'll be okay. I mean, at least it knows that it has 4 processors now. Up until very recently, I told it had 4, but Windows only picks up 2 because of sockets and licensing, apparently. So now, if I open a terminal as an administrator, and I'm going to hopefully turn sounds off on that. We said to install Git, it is win-git install git.git. And I think I am apparently on Wi-Fi, so it will, it will apparently download and install it, or download and install something. And as mentioned, this is relatively bare bones, and I'm realizing that might be a little hard to see, but if you trust me, it's just win-git installing git. Make it bigger, I think. And so, yeah, it's easy enough to just install and wait to download, because I don't know if you can actually pre-cache that sort of thing with GitHub. I know I had a fallback if the internet wasn't there, and that was a chocolatey package. But we felt like for this to lean into the whole, we're not representing chocolatey. We would use not chocolatey to install things. And what I do remember from at least the last time I tested this is, so once it's installed, I have to close that terminal and launch a new terminal. This one won't be as an administrator because, as we all know, you shouldn't run as an administrator regularly. But now we have the git command, and we can just run git and get a bunch of output to the screen. And so we had hoped to have 2 laptops so I could read off of the slide, but that's not.
We're looking to do git config.
Yeah, so we did git config -- global user.email and typing. Actually, so I mentioned like this is the bare minimums of Git, or what I consider the bare minimums. But let's leave that off for now. Help.autocorrect. And then we'll set that to prompt. And to give an idea of how the help works is, or how that one works, and just to demo it instead of just saying, hey, that's how it works. If I were to just type git config, but I missed the C, and then global, I'm going to use user.name for right now. We're going to say my name is Cory because that is what I tell everyone my name is. And so this is the prompting is that you called it onfig, which doesn't exist, run config instead, and I can just hit Y for yes. And now if I do a git or git config -- list, it lists out the configurations, and I can see that my user.name is Cory. And I'm trying to, if I forget that I'm not at my computer and I do a git f, the one thing that this won't do is when you're in, if there's more than one command, it won't prompt you to run it. It'll just say, here's the however many commands, and then you have to figure out which one you meant based on that, which is probably a good thing. It's also actually the reason that I prefer prompt instead of just running it, is because I'm fearful that I'm going to type something and Git's going to say that's not a command, and it's going to pick something different and do something I don't want it to do. But I also can't think of any command where it would actually do damage. So this is that's the like getting started, getting Git installed now. From it being installed, we can now go and use it. One of the things then you might have noticed that I purposely left off so far was I hadn't set the email. And the reason I hadn't set the email, I'm realizing now, is I wanted to demo, but I'm not going to, I think, for a bit, is the reason that I would suggest setting your name and email in your Git configuration, and definitely setting it with global, is because if it's not set, especially on Windows, Git will try to be helpful. It'll try to figure out what your name and your email address is. Now, if you're in an Active Directory environment, it might be able to. I think I don't know if it queries the Active Directory or if that information is just on your user account. But I've had it at least figure out parts of it. It seems to look at logon domain and username to figure out your email. So in the case of a former employer, I was Knox, and the domain was their domain. And so it would pick that up, which my email address was actually Cory_Knox. So this is kind of why, one of the reasons I also suggest doing it is that you're able to be very specific about what email it uses. The git config command also has, so this was using -- global. You can also use -- local. So when you're in a Git repository, you can do git config -- local, and it will set the configuration inside of that.
Inside of that body of work, basically.
Yeah, inside of that repo, so that maybe you have Git repositories that you're going to use for work, and you want to use your work email, and then you do open source work on the side, and you want to use your personal email for that. You're able to do, for each repository, have a setting. And I think this is the part where technically we would go back to the slides. And the next slide was asking if there's any questions. So I'll ask if anyone has any questions. Missy? Yeah. So for help.autocorrect, the default is 0. It can be any, if I turn this back on, and it wasn't on the screen, so I have my notes here. So it can be 0, which is the default, so just show the command. It can be a positive number, but I think when they say positive number, they actually mean positive integer, so no decimal point. And that's the decisecond, so 1/10 of a second, for how long to wait before it automatically runs it. It can be immediate, which will run it immediately. You can prompt, which is, as I said, the one I suggest, and will just never prompt.
Hey, Cory, a good example of that would be, how can we show the help of that command actually inside of Git?
That's an excellent. And we can do that, maybe, if this all works. Okay. So if we did, Git config, actually all Git commands have a -- help argument, and so you can run -- help. One of my complaints, in my personal opinion, is that if you're a command line interface and someone asks you for help, you should give help in the command line interface. This is just kind of my opinion, though. Apparently, Git does not share my opinion because it
Goes to an online resource.
Well, it doesn't even go to online resource. It ships with HTML resources, and it takes you to the HTML. At least on Windows it does. I believe on Linux it might not, and it definitely wouldn't if it knows you're on SSH, if you're SSH in. But that being said, a benefit of the web browser is you can, if you figure out where the keys are on the keyboard you don't normally use, you can search. So we can actually, what was it called?
Autocorrect.
Autocorrect. So we can search for the help.autocorrect, and it can, so we can get to the help for it, or yeah, the help for it. In the case of the git config command, which is what it's showing here. It shows kind of all the other ones that it knows of. I believe you're actually able to set things that it doesn't know are config things, and I think some tools take advantage of that. So they can pull data out of the configuration. I could also just be making that up, so don't. You could try it and see if it works, and if it works, great. Actually, one might argue it's not great, because if I do a git config help.auto and I say Bob, and I actually type it -- global. So I can do a git config -- list. So yeah, it will take any command or any property and add it to your config file, which is helpful, but also not as helpful. And so from there, if there's no other questions about the installing and kind of just getting started with Git, we'll move on to once you've got Git installed, well, your next step is you're probably going to want to get your repository started. And your repository, to get your repository started, you're going to want the git init command. which according to help creates an empty Git repository or reinitializes an existing one. I think I have used it to reinitialize an existing one maybe 5 times if I'm being generous. I would Git init is probably more often than not you're just going to be initializing an empty repository, and not only that, this is probably like one of the commands you're going to use least often, but is important to know because, or actually maybe it won't be using it the least often if you're setting up or if you're initializing new Git repositories. For myself, most of the time I'm not initializing, I'm pulling from GitHub or GitLab repositories that already exist. But this one,
these are for those rare instances where you actually write your own code and don't just find it on the internet.
I write my own code sometimes, and sometimes not. And then I put that I think I had the intention, or I had the thought that this was going to be easier because we were going to be switching between laptops, but this is also still just as easy. So to do that, to use Git init, you click in so that you just type Git init and you give it the name of what you want your repository to be called. I don't know, let's call it Summit Demo. I'm realizing I've never tested if it works with spaces, but if you put spaces in your file paths,
You're monsters for one.
I was going to say you're a bad person and you should feel bad, but
Yes.
apparently you're monsters. Do not use spaces.
Windows and spaces. No.
Sorry?
Windows and spaces. Then there's quoting.
Yeah.
No.
And let's not talk about program files though. At least we don't have documents and settings anymore. So now we have, I don't know what I was going to show with git init command. Like you run git init and then it's there. And we haven't talked about the other commands that I could run to show you. I'll do.
I was gonna say if you do an output of it.
There's nothing in here.
Yes.
If I do a get child item, there's nothing. Except that if I force it, then so we get a Git directory that's hidden, or .git. The dot is actually important because that's actually where Git looks, and everything that's not Windows treats dot as hidden files. So so we've initialized that initializes a Git directory or a Git repository, and that Git repository, there is stuff in that .git directory that you're not.
Essentially, it's just keeping track of the changes.
Yeah, and like being initialized, like there's stuff in there, but there's not really any. There's no data in there yet, and so that's where we want to talk about working with your repository. I'm seeing things on the screen that seem. Never mind. I just have dust on my screen. So the next command is git checkout, and this is you. So remember back at the beginning, I mentioned that we're just going to talk about one way of doing Git, and there's lots of ways of doing Git. The checkout command is kind of one of those things. The checkout command, I believe, dates back to like 2005. It was one of the first commands because they use checkout in all the other version control systems. And they use it to mean switch branches or restore working tree files, which means that you can run, checkout doesn't tell you necessarily what, or it doesn't do one thing, it does a whole bunch of things. And the thing, and part of the reason I'm showing that one is I've been, as I said, I've been using Git for years, since before they now have a switch command and a restore command, which do switches the branches and restores the working tree. Although you can use those, I have muscle memory of typing checkout, so that's why we're covering the checkout is used to check out your not your working tree, check out your branches and move and restore files in your working tree. Except I'm not 100% sure on how the restoring ones work, because I cover restore later. So, once I know why I had it. So the first thing you want to do is checkout, and so you use checkout to create a branch, so that you can work in your repository. And then once you've checked out a branch, down means go forward. I'm going to forget that again, but once you've checked out your branch that you want to be working on, you want to git status is the next command that you'll likely be using, which is the help says it shows the working tree status, which is exactly what it does. It tells you what in your working tree has changed, what files might be new or deleted or changed. And then once you know what's new or deleted or changed is where you would want to use git add to add the file into the index. And this was why I mentioned earlier that index is what Git calls the staging directory, or the staging area in stage content, is because taken direct from the help file, adds file contents to the index, which
is your stage area.
I would argue the help would have been better to actually say staging area or something like that, but I'm not a Git contributor, so yeah. Now, I'm realizing how bad these slides are, but so once we've when we're working in a directory, we want to track changes to the working directory and kind of know where we're at, and we can run the git status command, which will tell you what's changed, and I am going to demo it shortly, but seeing what's changed isn't, if you have to run git status every single time, it can be quite overwhelming. It can also give you an awful lot of output that you may not actually be interested in. And that's where posh-git, or that's another place where posh-git can come in, because posh-git by default, if you haven't configured your prompt, it will give you the status in your prompt. So it'll tell you what branch you're on, as well as what your status of your repository is. And then from there, we have git commit, which records changes to your repository. So these are the ones that we have added to the repository. And once you've added them to the repository, you want to commit them, and you would use the git commit command, which takes us up to demoing these commands that I am absolutely not going to forget where we were. So we did init, and we said we'd check out.
Yep.
So let's do that. Smile for Ebony. I don't suppose anyone in here uses VMware Workstation, do they? And can give suggestions as to why this keeps happening. Control Shift Escape. That's not the task manager I want. Send Control Delete. Okay. Not full sleep settings? Is that what I heard someone say? You're probably right. I think let's go into the good interface. It is turning this, I bet you it's, turn the display off and you know what, let's make it high performance because we are high performance people. It also started at a much higher resolution, which might be why, or might be why it doesn't come back the right side. So,
I'm gonna do a git checkout to create our
thank
branch.
you. So, git checkout. So the great thing about git checkout, as I mentioned, is it does a lot of things. And one of them, and the way that I always do it, is to create a branch. You have to, if you're creating a new branch that doesn't exist, you have to give it the -b command, which stands for branch, I think.
Yes.
The switch command uses -c, which means create. And if you were to go off of like use the command for what it's supposed to, you would technically use branch, which again is very helpful to. But the trouble with using like something like git branch to create the branch, and then you have to git switch to just switch over to it, or git checkout. I always just do git checkout -b and my super cool, not at all ridiculously long branch name. So I have now checked out my new branch, and I'm over here, and I can see that by running git status, and it tells me that I'm on branch, my super cool, not at all ridiculously long branch name, and I can continue with working on things. But what if I wanted to go back to the previous branch that I don't even know the name of now? The great thing about git checkout and technically switch is that this is either going to work because I'm remembering it correctly, or it's not. If it doesn't work, we'll scrub it from the recording, I'm sure, definitely. But if you run git checkout with just a hyphen, it will actually take you back. No. Okay. I might not have been on any branches. Pretend you, wait. I think it's because I don't have, we haven't covered git log yet, but we're going to cover it soon. And I think it's because we don't have any commits, so therefore there's no branches don't have anything that they're pointing at, which means that it's not helpful. So what was the next command after Was it? It was add,
It
wasn't
was
it?
add.
Okay. So
At this point, we have to make something with change.
So we're going to create a new file. I don't know. I'm really amazing at naming things. And we're going to do notepad script because this is a bare bones VM, so we don't have much on it. And write host considered awesome. And we'll just close that, tell it to save. And now if I do a git status, apparently with 2 S's because we want to demo the autocorrect again, and definitely not because I typoed, and we choose yes. So now we see that we're on our super cool branch, and we have our single script, PS1. Apologies for the colors I'm realizing. Blame Windows, I guess. But so it says like nothing's been added to commit, but it shows us that our script.ps1 is what it calls an untracked file, and we can add it with git add file, and it'll be included. And so
Effectively, at that point, we'll put it in the staged or index.
in the index, yeah. So we'll add that with our script. And now if we do a git status, we see our new file, and we see that now it's changed from red to green, and tells us that it is a new file. And this is kind of demos the running git status all the time to get this same or this output is cumbersome at best. So we're going to install module poshgit. Okay, and we're going to scope it to current user because again, bare bones VM forgot about some of these things, and I apparently don't have haven't updated PowerShell get. I'm looking at the time. We have a few minutes before. Oh wait, no. In about 6 minutes is when you're going to be talking,
Yes.
and I'm going to go get food.
Okay.
So now we import poshgit, and so now this is the default prompt when you don't have a prompt, and so it tells you various things like what branch you're on, as well as it being green here means that it is the stage stuff. If I do git reset, which will cover. Don't push the power button that's right above the delete button. Because apparently it's really easy to just push the button and I really hope it just went to sleep. 'Cause,
Yes.
Don't look. Okay. I think it's with dot. Yes. Okay. So when it's red, it means that there are. Okay. Let's see. Windows P. It's back. Again,
Okay.
You didn't bring the goats, did you?
No, not enough of them.
So when it's red, it means that there's changes to the local directory. We'll see it a different color than green shortly too. Let's do a new. Oh. Okay, type I'm just going to copy script to be script 2 because reasons. And so if we do git add script 1 or 2, apparently there's no script 1. So when we have multiple, like the default, it shows like this. It's also not terribly great at the moment because some moron picked a really long, ridiculously long branch name, you might say. But I digress. We'll carry on. Once we've added it to the index, we want to commit it. And so we run git commit, and if you just run git commit, it's going to open the default editor. Actually, no, it won't in this case. In the case of this, this is why I mentioned you set the user and the email, is that if it doesn't know what your user, like your email is, it tries to figure it out. And in the case of, it tried to figure out my email address, and it decided that my email address is corbob at corbob-win11, actually, yeah, win11.none, because I'm not on a domain. I'm not on a network that is giving me a
FQDN?
Sorry? On DHCP, it can, the DNS lookup address. It's not giving me that, so it can't make a guess as to what it thinks my email address should be. So it yells at me. And in this case, I think if it detects that either one of them it can't figure out, it just tells you about both of them. But we're gonna take their example of an email, and you will want to actually do this. Don't do what I'm doing here, but because you're not you at example.com. Neither am I, but I'm demoing, so I get to do what I want. So now when we commit, it opens the default editor, which is the best editor, which is Vim, and we're going to tell it that we're in dark mode so that things are kind of visible. And then we have to give it a commit message. And a commit message absolutely must, this is the rules of commit messages. And if you get nothing from this, no, it starts with open parentheses, the hashtag, the number of the GitHub issue that you're working on, close parentheses, space, the title of your commit message is my commit message that goes no more than 50? Josh, is it 50? It's 50. Goes no more than 50 characters long, and it shows you down at the bottom here that we're at 33. And then there's a blank line. And then I did some really cool things. All of these can go no longer than 72. This is the way you have to do it. Git will break if you do it any other way. Or you just put whatever you want in. I mean, you just say, hey, and then it's committed. And because it's Vim, everyone knows how to quit Vim, so I don't need to tell you that it's :WQ. But it would be actually probably is good to mention. I don't know how many people here actually use Vim or know how to quit or anything like that. There is a git config for the editor. And so I'm gonna pull that up just before we break for, there's snacks out there, right? Okay. I'm gonna find, no, editor. Core.editor is the name that you want to set. So what we'll carry on with after we come back from the coffee break is actually setting that so that you don't have to. I was able to quit Vim. Some people might have to shut down the computer to quit Vim. So we'll help you not have to shut down your computer after the break. So we're definitely going to go off script because we definitely had fully prepared everything and haven't been winging any of this. So to carry on from where we kind of what it was half an hour ago and I can't remember what we were doing.
So I've worked
That's
with a local.
interesting to me. Sorry.
We worked with creating a local Git.
We've created a local Git directory. We've set up our email address. We've committed. A question that came up during the break was about the. Let me add the file. So one trick you can do with git add is if you give it dot for your local directory, that's going to work perfect because I'm definitely not going to kick that. Which is true because I haven't moved over that way at all. But you can use dot to add the entirety of the local directory. That can sometimes be dangerous. Because it will add all tracked and untracked files, which we haven't really covered any tracked files yet that have changed because we've barely gotten them in. But the question that came up was regarding git commit and again set bg equals dark. And so I had made the tongue-in-cheek comments about that the message absolutely has to start with parentheses, a hashtag in it, or octothorpe or whatever, the hash symbol, and a number, and then close parentheses, and why that is, and also a bit about why it's tongue-in-cheek. The commit messages can be absolutely anything you want. If you've ever worked with GitHub Actions or any other CI/CD system or seen the commits generated from people working with them, a lot of them will just be, and I know for myself it definitely are, just something or maybe this needs to be true or let's try this again. And then when it's done, you do some magic that hopefully we're gonna cover as I put my timer on again, and definitely do it 4 minutes in instead of 10. It's getting better. By the end of the week, I don't have anything else after today. So, but I derailed my train of thought. Myself. Okay, yeah. So if you're using CI/CD, or if you've seen the commits generated by someone trying to get CI/CD to work, there is an awful lot of trying this something and just asinine commit messages that don't mean anything, and then when they get to the end, they'll do what's called a rebase. And just get rid of everything and just say, oh, first try, because clearly it was only the first try. That's what the Git history says. So the commit messages don't need to be in these specific ways. But we use that's what we use at Chocolatey, you start with the identifier of the issue that you're working on. So that's the open parentheses, hashtag, and the number. And one of the things that gives you is in GitHub or GitLab, and I suspect the other Git hosting providers, is it links it up to that issue. So oftentimes when you're looking at it in a web interface, you'll see you'll see it and you'll be able to click on it and take you to that issue. But the 50 characters and the 72 is also important in that it comes from the time when terminals were only 80 characters wide, because that's when Linux comes from, and there's a lot of stuff that goes back to 80 characters, even though we all have wide screens now. But even though we all have wide screens, we oftentimes our Git, when we're working with Git, if you're working with it in your editor and looking at your commit messages or anything else, it won't be the full screen. It'll just be like a toolbar on the side. And so the 52 characters, the 50 characters of the very first line, which is the title, or often displayed as the title, allows for additional information that often comes with that title. So there'll be the commit hash, which is Git's reference to that commit, which will usually be about 6 characters in length, as well as your possibly the date or who committed it. So that gives you room to expand without cutting off. And then the 72 is, again, on some things that are narrow, it allows without word wrap, because one of the things as well is that when you're committing, you have control over that word wrapping. You have control over when line breaks happen, whereas if you just type it all in one big long line, and then you commit it and someone opens it up in their terminal and they try to read it, and it gets halfway through a word and then it decides to line wrap, that's not a good experience. So yeah, the commit message can be absolutely anything you want. And before I actually commit this one, I'm going to quit this and do what we said we were going to do at the beginning. So I can do git config -- global and type properly. And then I think it was core.editor. And I'm going to say notepad.exe. So now when I just run the git commit command, it opens in editor. And apparently, I don't know how that new notepad feature will work with this message, but I also don't normally use Windows 11. So be aware of that if you're going to use Notepad as your editor, apparently, because I think something happens where it'll load, like it tries to remember it for you. I can say just this is our commit. And one of the things about it, the default commit message, it does load up like this, what we have on the screen, which shows you, like it gives you all the comments and kind of describes for you. Which kind of why I glossed over it earlier. As well, it gives you kind of the information about the changes that you're about to commit. So you also have like another chance to look back and say, oh, well, actually, I don't want to do that. And then once the file is saved and the editor is closed is when it finally, when it commits. If you don't want to actually commit anything, you just close it. Otherwise, it'll commit them. And now, is git log the next one?
Yes.
That we had on our list? I think, yeah, actually, we kind of planned that we were going to talk about git log after the break, but didn't actually, thought we were going to get beyond git log before the break. So now we've come back from our break, and it gives us the perfect opportunity to actually say, well, what have we done recently? And by default, git log gives us, this is the output. It tells us the information about our commit. Head is, I'm realizing hadn't discovered head, and it is actually a very important concept in Git. And head is how Git refers to where Git happens to currently be. A way to describe that is, just let me Install Git Kraken. I don't know if Git Kraken is on Winget, so I'm using Chocolatey here. But so while that's installing, head is Git's pointer to where you currently are in your repository. And so in this case, head is pointing to my super cool, not at all ridiculously long branch name. And it's in particular pointing at the first commit in here. And this other commit is the one that came before it. And log just kind of gives us the details of that. You don't have the latest slide.
Version control.
I know you don't have the latest slide because there is no help on that screen. Okay, coffee break. Wait, yeah, okay. That is where we would want it to be. But we did add. So I think, because we totally practiced it and are professionals, we were supposed to come back to slides and not necessarily the demo part. Yeah, so we were at coffee break. I thought I was much further behind than we were, but apparently not. But you'd see the difference, right?
Yes.
Okay. The joys of version control and working with multiple people, obviously, is the I have one copy and he has a different one, which hopefully we'll get into shortly. So I thought I hadn't talked about log. So git log shows your commit logs, and it shows you how to, it shows you the information about it, it shows you the commit and the head, and this is actually perfect because Git Kraken will be ready by the time we get to it anyways. And along with git log, so git log gives you kind of your commit details of the commit message that you gave it, who committed it, and that's generally it. But git show shows you various types of objects is what the help does. In most cases, you're just going to be asking it for commits or branches, or maybe not. Maybe you'll do more than that. I guess I shouldn't make assumptions about how you're going to use Git, especially since my way of using Git is constantly changing. But it shows you more details about it. In particular, it shows you, I use it to show the change set and show the diff of what that file or what that change actually did. And then after show, we have git reset, which resets current head to the specified state. And this might have been where I actually intended to talk about head, because I remember having seen it and made a note in my head that I needed to make sure I talk about head, because Git, I think head comes from like the version control systems that came before Git. That's how they used it, and that's therefore that's why they still call it head. Another way you could think of is just the pointer, pointing at where we currently are. And then reset is another one of those commands like checkout. It can do a lot of like various things. One thing that you'll often see is running git reset -- hard to wipe out all your changes in the working directory. I would lean towards using git restore, which restores your working tree files. In particular, you can give it just individual files and it will restore just those. And that's, so you've made changes to the file and you decide you're not going to keep those changes for whatever reason. A common one for myself is in some of our debugging, we have to set certain things in the programs to be certain ways, and those don't work once it's out in production. So you make that change, you do your debugging, and then you can just git restore to get rid of it. Git stash is to allow you to stash the changes in a dirty working directory away, as the copy and paste off the help says. And a dirty working directory is just one that has changed and you've made edits to. Okay, I was questioning whether I just had a whole list and didn't actually have planned stops, but that's a lie. And git clean, before we go into more demos, git clean is probably one of my actually most used commands, and it removes untracked files from the working tree. And because all the other commands that so far have worked mostly like with tracked files. So if you git restore or git reset, you can only restore or reset the files that you're tracking, whereas git clean will effectively get rid of the untracked files, which we'll cover how to untrack. Hopefully we'll cover how to untrack later, or how to not untrack, ignore files later. So I think you have the right order there, Ryan. It's the,
Yep.
it's the,
Have the Cliff Notes version.
So we covered log, and actually the intention was to come back from break and to cover log, because as we've demoed, I can't remember what I did half an hour ago. How can I remember what I did a week ago? Therefore, log allows you to see what you've seen. Log and number of, so we get log. The other one is git show, and show, in this case, we don't have many commits again. Wait. Why is, so git log will show you a log of multiple things, and you can be more specific, and so we can give it the commit hash, which is this one here. We can either copy the whole thing, or you can get away with usually about 6 characters, I think, is it 6 or 8?
I think it's 6.
Or sometimes one, sometimes the other. Basically, Git will allow you to, anytime you're working with these things, you can give it a commit. You can either give it the full commit, or you can give it similar to PowerShell parameters. You can give it just enough to uniquely identify it. So like if you're doing, in PowerShell, you do select object, you can do -expand instead of -expand property. As long as you get far enough to identify it uniquely, it'll figure the rest out. Which means that I can do it with even 5, which is fewer than the 6. But so git log, you can either just run git log and it shows all of them. You can give it a single commit. You can also do git log hyphen and then give it any number, and it will give you just that number of commits. So if I give it 1, it'll only show me the last 1 commit. This might be a good opportunity to see if we have any other branches, which I bet you we don't. But now if I do a git checkout -b. I was gonna put in a swear, but I suspect we shouldn't. Checkout -b. Hello, because I am very unique with my branch names. But to demo what we tried to demo earlier, now if I do a git checkout and do dash, yes, I knew I wasn't losing my mind. So when you have branches, you can switch back to the one you just came from with git checkout dash or git switch dash. Will both take you back to that previous one. And the which is helpful in cases like this because I really don't want to type out my super cool, not at all ridiculously long branch name. But in the case of that one, to demo the posh git, and one of the reasons I love posh git is that I can do git checkout and I hit M and then hit tab, and it just figures out my commit or my branch name for me, and I didn't have to type it out, especially since I would probably type it spelling super correctly, because I definitely would not have typoed that earlier either, except that I was demonstrating, so that's the only reason typos happen, right? Okay. So I'm going to switch back to this shorter one and actually demo some things about reset, because reset's the next command, or at least
Yes.
that's what it says down there. Reset. I know what I wanted to show, because it's going to lean into, so new item, bad. Oh no, it was good compression file, wasn't it? If anyone's following the XZ debacle, but bad file, PS1. So with the git reset command, as I said, there's a number of things we can do. One of the one that I do most often is if I add. So I've added my bad file into my index, and I decide that actually I don't want to commit this file. The way to get it out is to run git reset bad file, and that will reset it, or it'll take it out of the index, but it'll leave it in the working directory. And I think even, I've never tried this with an untracked file, so we'll see if it works. Okay, apparently I didn't remember that I can't do it with paths. So if I do a git reset hard, that's where, so git reset hard will take, clear out your working directory of any changes, whether they are in your index or not, which is handy for when you're working with remotes. I use git reset hard all the time on the remote side because it allows me to keep my local branch in line with the upstream. In the case of, it's usually chocolatey software. Like for the Choco command, it's much easier, or I find it the easiest way to get that in sync. And so the restore command is used to restore the files, whereas give reset also restores files, this is the fun part about Git, is that, as I said, there's multiple ways to do it. But in my experience, I find it easiest to use restore to restore files from when they're changed, which means I actually have to change a file. So is considered harmful because that is So don't forget to save, apparently, if you have this new tabbed notepad. Otherwise, it'll just keep it and not actually prompt you to save. But now we have a changed file, and so we can run git restore, and then we have to specify the files that we want to restore. But before we do that, let's look at git status. And we haven't covered git diff. Did we say we're going to cover diff?
No, not yet.
Not yet, but did I do the dumb, and do we actually have 25 that we need to cover? Okay. So a 25th command to cover is git diff, which is actually, I think, quite important because you often want to see what you've changed. And especially when you're picking what you want to commit. So git diff, we're going to pretend that we have a slide. And git diff means show changes between commits, commit, and working tree. So perfectly simple. In practice, so you would run git diff, because I made changes to script.ps1, but I don't know if I want to commit them. And status just tells me that it's changed, but it doesn't tell me what's changed. So diff actually tells me that in this case, it's not always the best output because it says, well, you deleted this line and you added this line, when in fact a rich diff would show us that actually we just changed the word awesome to the word harmful, I think.
Yes.
But it also might have, no, it would have told us if it was encoding change, I think. And so what I'm actually going to do now that I'm on a new branch is I'm going to commit that. And because I am not at all lazy, I'm just going to do -am and give it a commit message. So with commit, we covered like that you can commit. But one of the things you can do with git commit is there's a lot of parameters on it. And one of them is -a or --add, I think. Don't quote me on that because I don't use the long ones. But so -a will add all of your currently tracked changes into your index, and then -m or --message is the message that you want to give it. And that will just do our commit for us. So now we can do, if we do a git log and just ask for the last one, we see that we just committed and we just gave it the description of harmful because we're following the guidance of having good commit messages. And that's why it says harmful. But also so with log, and now I'm realizing I'm jumping all over the place. But log allows us to, log has a --all, whoops, wait, yes. I bumped the doc. I want to make sure. So one of the things, I'm not going to do -- all because I'm not actually at a divergent where I would need it. But what the log can show us in this case, because we have multiple branches, we can see our previous branch of the super cool one, and it's still in our history. And so when we launch a graphical interface, and now I use Git Kraken, which is free for open source, but otherwise a paid one. And I'm just gonna, oh my goodness, user, it's users. Summit demo. Okay. So it's not going to ask me anything else, is it? So in the graphical interface, we can see like this is a graphical representation of this same Git log, and we can see the my super cool. If I can make things bigger, our long branch name. I'm getting tired of saying it because this is why you shouldn't necessarily make them long, especially if you're going to have to talk about them for a couple of hours. Words that I have. We can see that like it's still there in it, and actually if we check out that one, and now if we run git log, we don't see the hello one anymore in running just git log from the CLI. In the graphical interface, we still see that it's here, but we also see, because of at least the way that Git Kraken's showing it, the check mark is where we're checked out to. There's a way to collapse this. And so, but sometimes we want to run from, or maybe not sometimes, but oftentimes we want to run from the command line, and we can see the same, or the same with --all. So it shows all, like the whole log, at least as far as the terminal will show us, and then it starts paging. And in this case, since we only have 3, there is no paging, but it shows us still pointing the head, so where we're checked out to. And then git stash apparently is what we said we're talking about next. So in the git stash, I'm tired, apparently, because there is no hello command, nor did I actually want it to hello command. So if we go back to our hello branch, which is much better than the command, and we now make some changes. Notepad script. Right host. So say we were working on this script for Jeffrey Snover, who at one point I believe had said right host is considered harmful, and also had convinced a room full of attendees at Ignite to yell really loudly "Mark who" when he said Mark Rusinovich, who happened to be across the hall. And I wish I could have found the video because I wanted to use it earlier. But so we're working on the script for Jeffrey Snover, and we've decided that the next thing we're adding to our script is that it's going to say Mark who. And then Mark comes to us and says, "Oh, well, I need you to drop that and work on something different. There are a couple of ways you can handle the situation. We could commit to our branch as it is and carry on working. We can also use the stash command, and actually, to demo the stash command, we'll call this Jeffrey. So to demo the full power of the stash command, say we changed our main script and we had this new Jeffrey script. Now, again, we can commit it, but maybe we're not necessarily going to want it to be called Jeffrey. Maybe it's nowhere near ready, and we just want to switch. We can run git stash to take what is in the working directory and stash it, for lack of a better word, put it away for later. And so we, by default, if you just run git stash, it will run git stash add, I think is the subcommand. But so it takes the working directory and the index and applies it into a stash, which Gitkraken gives us a way to visualize this. And so we can see that one is there. And then so we go and do our work for Mark, and come back, and we want to carry on our work for Jeffrey. And then we can just run git stash pop. So stash can be considered in computer science, it's a heap, I think. I'm hearkening back to my college days, which are stack. That's the one, I think. It's a stack. So you last in, first out. They apply on the stack they basically put a commit on top of it, and then if you issue the pop command, it will pop it off of the stack and it'll take it off. And assuming it applies correctly, it will delete it from the stack. If it doesn't, then it actually stays on the stash. But in this case, it works just fine because we haven't actually changed anything. For me, one of the what I've actually learned recently with stashes that I found powerful is that I can do git stash, and I can do -u, which is to stash the untracked changes as well. And so now it's taken our modified script.ps1 and jeffrey.ps1, and they're in their own new stash, and we can go back to our stupidly named branch, and now say we want to actually remove that and git commit. We'll give it at least a half decent. And now when we, and another, actually this is, stashes can also be used in this scenario where you've done a bunch of work and realized you're not actually on the branch that you meant to be on, where you're supposed to be doing the work. Instead of committing it, moving it over, and then trying to bring it all over there, you can just put it onto the stash and then do a git stash pop and bring it off. And this, if I did this right, this demonstrates that the pop only deletes when it applies cleanly, and in this case it didn't apply cleanly because it was deleted. That one of the scripts that we were editing was deleted, and so we have a conflict. and I'm realizing I'm demoing this and I have no idea how to fix it from the command line. Oh, yeah. So in this case, we're going to tell it that we want to delete it, and now, and then it's applied it, or applied the other change from here, which it's not showing. So. But clean. I don't know why I wanted to talk about clean this early. Probably because it's not to do with remotes. So with clean, we use clean to clean the. I hate that the that the names for it is just the easiest way to describe it. But it takes your working directory and will clean it of any files that are not tracked by Git. And by default, actually, if I recall, it doesn't actually do anything. Yeah. So by default, you actually have to give it what you want it to clean, and so with -n, it will just -n is kind of like -what-if in PowerShell. It'll tell you what it would clean, but it won't actually clean it. And then by default, we would then either have to give it I for interactive or F for force. And in this case, so I give it I, and it asks me, do I want to clean Jeffrey? Because I've only one file. So I'll choose to clean that. And now we're back to, we got rid of that file that was untracked. One of the powers of git clean, though, is that there's X and D, and so I run git clean -xdfn all the time, and X cleans the git ignored files, which I know I have a slide talking about it later on. In Git, you can have a .gitignore file, and you give it the names of files, and those files will be completely excluded from Git. So, they won't be included. Common things that you might include in them, and I'm trying to think from a PowerShell perspective, because I'm realizing a lot of what I do is in software. But say your build process creates an output of your built module. And so you might have the output directory, you put it in gitignore so that it doesn't, because you don't want your combined module file to be in source control, because it's not needed to be there, because you're not actually making the changes in source control. So you would add it with .gitignore, and we might as well actually show it. So if we do gitignore, and yes, I want to create that file. And now I'm just going to put jeffrey.ps1 because that was a file that we had used. And I apparently hate working on laptop keyboards because I have an Ergo Docs, and all the keys get moved around. And so now we're gonna add that gitignore, and we're just going to keep a, right. So git commit -a, the great thing, actually, the nice thing about -a is that it will only take tracked files. So that actually did nothing because I need to git add the git ignore, and then I can commit it. And now if I do copy, okay, fine. New item, Jeffrey.ps1. So now when we look, that wasn't supposed to happen.
Oh.
So in your git ignore file, don't use Notepad. Okay, so the git ignore file, very important. Git ignore needs to be called .git ignore. That's it. Notepad insists on everything having an extension because Notepad. So now, if I do a git status, the gitignore.txt that if I was paying attention up here, I might have noticed. Yeah. If I was paying attention, I would have noticed that, but apparently I wasn't, and neither was my helper. So with the git ignore, now when we do a git status, we don't see the Jeffrey.ps1 now that we've actually done it correctly. And so I'm going to add things and commit things. LKJ because it's easy. But if we look at the directory, we still see Jeffrey.ps1. And this is where git clean -xd fn comes in, is that it tells us that it would be removing Jeffrey because I think it's the X. And if I'm not mistaken, D is to delete directories if they exist and are not being tracked. So that's where git clean comes in.
Slides.
Is that then back to slides? Did I leave anything for you in this last bit? Yes. Okay, good. Perfect. Because I totally remember what I put. So, why are we working with remote repositories? Which gets us to the end, or the end goal of using source control, I think, at least for me, is to use is to share with others and to work with others, especially when using Git, which is a distributed version control system. And so move on into working with the remote repositories, which is
GitHubs or GitLabs.
Yeah, GitHubs and GitLabs. It can also be just a directory on a file share if you wanted. I'm not sure that I would necessarily do it, but it can be done. And so in order to do that, we use the remote command, which is used to manage a set of tracked repositories. And a tracked repository is just, it's typically a name and a
URL reference.
URL reference or a path, whether it's SSH or HTTPS or something. It configures the way to talk to the remote and tell it where to go to get it. And once we have remotes added, this is not the. Once we have a remote, it doesn't do us any good to keep it on our system, and so we have the git push command, which I think this is one of the ones that alluded to at the beginning, the help of update remote refs along with associated objects. Okay, but what are remote refs and what are associated objects? So git push is used to take what we have on our system and push it and effectively upload it to GitHub, GitLab, or what have you. And then once it's on one of those systems, for us to get it back from, so I push it up to GitHub, and now I've deleted I've re-imaged my computer, and I want to get back. We use the git clone command, which will clone a repository into a new directory. So it'll take from that remote and push it up to us. Does yours have this next part? Or once we've cloned it down, though, it doesn't do us any good if so I say Ryan makes an update to our docs repository, be a perfect example, and I have a copy. I'm going to take a drink. So I've got a copy of the repository, but Ryan here's made changes to it, so I need to get them back on mine in some way. And so that's where the git pull command comes in. So git pull, it fetches from and integrate with another repository or a local branch, is what I actually never noticed the local branch part before. I'm not sure I've ever used that, but so that's how you would get it from the changes on GitHub and get them down to your local copy. However, I'm going to tell you it's a dangerous command that many people use without understanding the consequences. So git pull it is often referred to and it's often said to use, and often it works just fine. I would say the majority of the times you're probably not going to have an issue, but sometimes you will have an issue. And that's the dangerous part of it, is that those sometimes don't come often, but when they do, you then have to undo all of that stuff. And so, as Regina George would say, stop trying to make pull happen. Because I'd love to leave it up, but while I actually talk about it, but I'll distract myself. So what pull does is it fetches the remote repository, and then it takes those changes that are on that remote repository and tries to merge them with the changes that are on your local repository. And where it can, and partly why I say it's dangerous and I recommend not doing it, is that in that merge, it tries to do the best thing for you, but sometimes that's not the best thing for you. There are some settings that can make it safer, or the description of the settings imply that it'll make it safer, but I've never tested them because I just run two separate commands instead. So then you're probably asking, if we're not if
If we're not running git pull, what do we run?
yeah, on so fetch
Yes.
as I can't remember what her name in the movie was, but so git fetch is the command that I'd argue you should run instead of git pull. And it downloads objects and references from another repository, but does not try to merge them into your local change. And so this is where we get into the, I'm semi-glad I prepared. Why is my watch buzzing at me though? Oh, wait, okay. So what do we talk? So we start with remote.
Yep.
Which means, so with remotes, we obviously
thing we
need a
need to do.
remote. Sorry?
We do. Probably the first thing to do would be close down the remote.
Well, in this case, we already have our changes, right?
Yes.
Because we have this one. So what we're actually going to do is we're going to go to seriously? I swear this worked. Okay, so we're going to go to GitLab. In this case, it's just running on another VM. And we're going to log in and really hope that I remember the password. Okay. Its password. Maybe. So one of the reasons that I actually wanted to use this container is for security purposes. This VM doesn't actually know any of my login details. And so the idea was going to be that I could clone things from there. That's not the one I want. Why did that close? Git. Dash. Okay. I think this is, or I'm hoping this is a result of me not using my keyboard and actually typing something different on the keyboard than what I'm typing here. Which means can I demo it, or do I need to use GitHub? Let's try a new browser and go to GitHub. Well, that wasn't quite. So I guess we'll use GitHub. And I will just try to be very careful. So to add a remote, if we're working with GitHub and GitLab and whatnot, we're going to want to create new you'll typically, in my experience, want to create the new repository in that remote setting. And so we'll call it Summit Demo before, I think. And I might as well make it public because why not? But one of the things I want to make sure, why can't I turn that one off? Okay, no. So this should create just an empty repository. And which means I can copy that. So now to add our remote, if we do git remote and just run that, we don't get anything. So we want to add our remote. It is, I think it's just add,
name.
and then we give it the name. A common naming scheme in Git is to use origin as the name of wherever your main origin is going to be. And if you do, when you do git clone, it uses origin. So in this case, we'll do git remote add origin, and we're going to paste the URL that was given to us by GitHub. And now when we run git remote, it shows us that we have origin, and we can give it the -vv. And it actually, so in a lot of Git commands, you can use the -v command to get some verbose output. And in some of them, you can do -vv to get even more verbose. An example of one that gives you something different with VV is branch. Actually, branch isn't going to give us anything different here. But normally it would, trust me. Normally, when you do git branch -vv and I say normally, but when you have a remote, it will actually tell you the remote that it's tracking against if you're tracking against that remote. But in this case, it didn't because I don't have a remote yet. So now that I have a branch, we get to the, or not a branch, a remote. We get to the git push command, which is now when we do git push, this is going to be the fun part. So my go-to is always to run git push and then always get this message because I created the branch locally, and so my remote doesn't know anything about it. So I need to tell Git what upstream to use. So in this case, so I just run the command and then copy it because otherwise I forget the exact syntax. And Git tells you the exact syntax every single time. So I figure why not let it do the work. It does, apparently you can tell it to automatically do it. But I've never thought to actually set that up because that would just make my life way too easy. And I am nothing if not a glutton for punishment, which means I need to figure out how to sign in. What does the code want from me? Oh, this is handy, I think. Can I, okay. Oh my goodness, why did it, okay. So github.com/login/device. Device. Enter the code displayed. 212. I'm not going to unlock that on. So, handy. I'm sure everyone's running multi-factor, but if you're not, this is a perfect example of why you should be, because why not make it more difficult to log in? But also, there's actual security reasons why you want to anyways. So I'm just being facetious about that. So now we've pushed up to our branch, and I don't even need to log in to, or not our branch. We pushed up to our remote. Now, actually, everyone can go to github.com/corebob/summit demo and see our wonderful, super cool, not at all ridiculously long branch as pushed up to that remote. And in fact, this sort of gets to the other part of the demo. If anyone wants to, they can also do the next command, which is git clone. I'm going to make a git directory and move in there, though. So if you do git clone summit demo, this will clone it down from the remote and set it up with the with everything that's up there. In this case, there's only one branch because we've only pushed up one branch. But if we wanted to, and not an if we want to, because we definitely want to, I'm going to go into the Summit demo here, and I'm going to check out hello. No. IPMO poshgit. What is, oh, okay, yeah. So now if I do a git push, I can't remember. So again, so we select it, and I just hit right click to copy and paste because that's handy. We push that up, and now we said git pull was kind of the next one, but we also said don't pull because of the potentially harmful ramifications. But what do you do instead? You git fetch. Are you? I think you're doing something with the Office clipboard, and it's coming through on, I don't know if anyone else noticed in the lower right corner, it said something about, like, yeah. I think every time you're tapping, it's doing something in PowerPoint.
Gotcha.
I thought I noticed it at one point earlier, and anyways, so if we fetch it, fetch will go out and get that for us, and so I didn't show that it didn't exist over here before I did the fetch, but we can pretend if I did a git log --all before I did that fetch, this one right here would not exist. Wait, no. these ones would not exist, I think. Maybe it's actually just this word that wouldn't exist. Now that I think about it and where I'm actually at on that repository. Yeah. So that's fetch and remote. And if I'm looking at the time, we're about 20 minutes, right? Perfect. Because I think some of the other, so some of the other commands that I wanted to discuss, but not necessarily demo and go through, is we'll call them advanced concepts and commands to be aware of. What I'd recommend with these ones is to know that they exist and kind of keep in the back of your minds like areas where you might need them, and when if you do need them, look more into them, or look more into them before you actually need them. In any case, git cherry pick is one. It allows you to apply the changes introduced by some existing commits. It is one that can be quite powerful, but is also kind of complicated and can be difficult if you're depending on how far changed your where you are is to where the cherry pick is coming from. So what cherry pick allows you to do is you have a repository, or you have a commit in branch A that you want that same change over in branch B. A perfect example of this is with Chocolatey CLI, where we released version 2 last year, but we still support for commercial customers version 1.x. And so if we have any fixes that we need to make in either 2.x or 1.x, we can make that change in the one, and we can potentially cherry pick it into the other one. But this is also where it becomes, it gets complicated and muddy, is that because in the case of Chocolatey CLI, there is it was a large changes that were made. So the code bases have diverged significantly. And so you cherry pick isn't always an option or the best solution, but knowing that it exists and that you can potentially take a commit and pull it over is good to know. Git revert allows you to revert some existing commits. This is very similar to reset in that it can take a commit that's there, and basically it'll just take a commit that's there and do the exact opposite of it. So if the commit that's there is like the very last commit, you probably just want to use reset or a reset to the commit before that one. But you can definitely revert to pull that to just invert it, to revert it. It's and in particular, like if you're using if you're on GitHub and it's like you've already pushed it up to GitHub on your master branch or something, and so you don't want to change the history of it, then revert would be the option there. I don't know. This probably doesn't actually make as much sense as it did in my head, but This is a classic Gilbert disaster recovery plan. I just changed it to say Git, and it's panic, because that's usually what you do. Git blame shows you what revision and author last modified each line of a file. This is only, it's only a part of it though, because it can tell you when a file was last modified, like each line of that file and who changed it, but it doesn't necessarily tell you that that's the person that introduced that line. They might have moved that line from somewhere else in the file. They might have moved it from another file. So it only gives you part of the story. But it's good to know about and to look into if you need to investigate like where something in a file came from. Git bisect is amazingly powerful, amazingly complicated, and I have used it professionally 3 times, I think. But I've given a talk on it. So it uses binary search to find the commit that introduced a bug. And this is very good in situations where you can see a bug exists in one spot but not in another. And you have ways to reproduce it, but you're not able to, like through stepping through things or whatever, you're not able to kind of derive what the cause is. It does a search across your code, and you just keep telling it, yes, the bug's there, or no, it isn't, until it finds the commit that introduced the bug. There are a couple of resources for that. Chris Gardner, who's here, did a blog post about using Git bisect and PowerShell. And then, as I said, I gave a talk last year on using Git bisect. This is like very much as I said, I've used it three times professionally in like the last 5 years, but knowing that it exists, I think, is the more important part about it than necessarily knowing how it works, because knowing that it exists, you can then go and find out how to use it when you're able to see something, like when you run into something that apparently we inserted the video and told it to play on click. Git reflog is another very powerful and also incredibly helpful help description of manage reflog information, because I don't know about you, but I know exactly what that means. It could actually be because I've used. But so the Git reflog is every action you take in Git logs it into what's called the Git reflog. So nothing in Git is, it's not nothing. Most things in Git are almost always reversible. Some exceptions might be if you delete untracked files, then you're not necessarily going to be able to get those untracked files back. If you delete changed files that you haven't put into your index yet, or maybe not delete, but if you undo those changes, you might not be able to get them back. But like once something's been put in Git, you're typically able to work your way back through it. The reflog can be very helpful in that, but it can also be very confusing and very painful to work through. Git work tree is copy and pasted from the wrong help page. Git worktree is basically branching on steroids. Instead of where we were working in a single directory with Git, and moving between branches in that same directory, you run the git worktree command, and it will create a new worktree or a new directory and check out the branch into that directory. So you can have effectively 2 copies of your, you can have both branches checked out at the same time in different spots on your file system. Git merge is join 2 or more development histories together. I found I want to say I've never used git merge, but I actually have used it occasionally. But that is at the direction of our release process that tells me to run it and exactly what to run on my computer. Otherwise, I always merge in GitLab or GitHub, and I merge from pull requests in there. So for me, git merge at the CLI isn't something that you're going to. Five more people? 5 minutes. I guess I got 8. So the reason I didn't really cover it is because I find that in day-to-day, I'm never git merging locally. I'm always using the tooling that's provided by the hosting providers of GitLab, GitHub. Those are the 2 that I use most often, but I believe all the others have merging abilities as well. So, and then since apparently 5 minutes, less than 5 now, I have a slide that I titled Git Good, and just some tip, I don't know, actually, now that I think about it. This was totally not put in just this morning. We'll just lean into that I wasn't editing everything this morning. But these are actually some learnings that I've in preparing for this. There's always be committing or learning. No matter how much you think you know about Git, you're gonna always learn more. Path spec, which I haven't even really got to cover, but had it in my mind that I wanted to cover. Anything that is referring to a file can be referred to through a path spec. So you can do things with path specs like */*star.ps1, and that'll give you all of the PS1 files across your entire repository. And that's where ls files and grep are actually 2 other Git. They're both Git commands. And ls files gives you the list of the files that are known to Git, and only the files that are known to Git. And grep searches through those files, and apparently Git grep actually searches through faster than GNU grep, and there was another one. So very powerful there. Some aliases that I wanted to cover but didn't get a chance, apparently. Git, so Git can do aliases. And you can use git config, alias dot, and then the name of the alias and what you want it to be. These are some of the ones that I have, so I can just do git f, and it will pull absolutely everything down from all of my remotes. There's git, what's commonly referred to as git log a dog. Does git log, it shows everything, it decorates it in one line and gives a graph. And I'm realizing I wanted to show that with the chocolatey one, but and one that I just added recently is, I don't know how many times I've typed git space and then gone and done something and then come back to it and type git space again. If you set an alias and you put a bang at the beginning of it, or the exclamation mark, like that, it will run that command. It'll run whatever you tell it to. So in this case, it just runs git. But that brings us into some gotchas. Don't necessarily run every Git command that you ever see on the internet, because that's like throwing gas on. You're already messed up. You might be thinking, well, why do I need Git if AI exists? Because according to AI, git branch -d branch name is to push changes. It's not to push changes. -D will delete your branch forcibly and just get rid of it. So you don't want that. Some fetch notes. Please, 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 if you ever have a GUI that says, do you want me to periodically fetch for you? Tell it no. It can get you into trouble. You can use git maintenance start instead. It's a command you can run on there in your repository, and it will fetch it down, but it won't fetch it down, is I guess the best way to say it. It'll download all of the stuff that it needs to, but it won't it won't update Git as though it did fetch it. So when you go to fetch it, it just moves some pointers around instead of downloading it again. And everyone else is clapping, so we got to. We already covered that one. We didn't cover hooks because apparently we don't have time. But it's a great way to have fun by messing with people. Devin's going to put developers out of a job by automating things, but we've been automating. That's what I've been trying to do for 10 years, and I still have a job. So, and I was gonna say if you wanted to learn more, go talk to Mike Kanakis, but Mike's mean.
We gave him 3 hours.
Thank you. And